Hello, Science Alliance. Hello, I am Lara. I was literally doing my hair, that's why I was late on. Like I say, you'll never know what it looked like before. Hello, so if you're new, because a lot of you are, I'm Lara. I'm trained to teach science to secondary school children, but I don't do that anymore because this is actually my job. Like, quite a lot of you are paying me a small amount per month. If you're new, don't do that yet. You might hate the lesson. I'll tell you about how to pay me at the end if you want to. We're learning about the polar regions. So we're doing 5 lessons. Next week we're doing all of the ice activities, and then we're doing all the animals in Antarctica and the Arctic and the northern lights and the southern lights, the aurora. But I thought for this one, let's just step back a little bit and just look at the big picture. Like, why are there poles? Why are the poles? Well, yeah, why are the poles? Why are the poles so cold? And what has Earth looked like before now? Because we're only obviously alive for like at this very set moment of time, but maybe the poles look different in the past. So first thing I want to look at is, actually the first thing we'll do is we'll make a paper spinner. We're just going to make a spinner throughout the lesson while I talk, okay? Here's my source. Thank you, Instructables. This person called Clone Stranger has done this. Yeah, it's really good. I haven't seen this one before. So some of you don't like to do activities alongside with me. If you sort of panic that people go too fast and you get stressed out, then don't worry, you can always just look it up and do it after. But I'll try and do it really slowly. We'll just do a little stage at a time as we learn about the poles. And then, yeah, in the end, we'll have this paper spinner that I am very impressed with. So the first thing you have to do is fold a piece of A4 paper in half. So it's like a book, yeah? Short ends together. And then, if I'm not going too fast, you have to cut that paper in half, okay? Scissors. There we go. That's all I'm going to ask you to do. And then I'm going to do a little bit of talking about why the poles are cold. Here we go. You need to have done this. Okay? Right. First reason the poles are cold, I was very proud of myself. Some of you have seen me do this already. We did a lesson on weather and climate, and I asked you to draw a circle on a piece of paper, and then I said to get a fork. You don't have to do that now, but I'll show you quickly what we did. I said, imagine that the sun is here, and the fork is like a ray of light, if you like energy travelling from the sun, okay? So if energy travels from the sun and it hits the Earth right in the middle, the equator we call it, let's draw a little line above and below our fork to show how much of the Earth got hit by that energy, right? And then do the same thing, same fork, just a little bit higher up now, travelling in a straight line again so that it hits, say, the top of the planet, like that. And then do the same thing. Just draw a line above and below the fork to show how much of Earth got hit by that ray of light. Oh, gasp, look, that line's so much longer. Can you tell? It's good that, isn't it? I was proud of that. Like, obviously the fork hasn't changed size, but because Earth is curving, at the equator, the energy from the sun is much more concentrated. There's like more energy per square meter or whatever. Whereas up here, Earth's, the energy from the sun gets more spread out. You see that? So because Earth is curved, people at the equator, that's why it's hotter at the equator and it's cooler at the poles. That's one reason. I don't know why I just did that really, because I've got it all on a little PowerPoint for you. I just really liked the fork thing. I wanted to show you. So here's that again with fancy PowerPoint effects. You ready? Sunshine shines on Earth. You can see that both those rays of light are exactly the same width. So it's the same amount of sun hitting Earth, but you can see that the area around the equator is much smaller, right? So you'd say that the sunlight is more concentrated at the equator. So I'm just blowing my nose again in the background. So the sun's rays have to cover more ground at the poles because Earth is curved. So the sun's energy is spread over a larger area, therefore cooler. All right. So that's one of the reasons why it's colder at the poles than it is, say, at the equator. But let's talk about days as well. Let's talk about how days work. Yeah, we'll do our next stage of the spinner after I've talked about days, right? So I'm a physicist. I've been teaching physics for like 10 years. But still, when I think about daytime, this is what I picture happening. And maybe you are the same. Maybe you're the same. So I picture morning and the sun coming up. It's called sunrise, isn't it? So I picture the sun coming up, and then I think, oh, like it's over our heads, and we say that is lunchtime, and then the sun goes down again. The sun sets again. We talk about the sun going down all the time. and that is a day. Obviously, that is just not how days work. So for a couple of reasons. One thing is, that's kind of what it's like in the middle of the planet, but because Earth is curved, most of us never see the sun directly over our heads. You should never look at the sun, but I don't know if you've noticed this, if you're in Britain like I am, the sun will never ever be over your head. It's only on the equator and a bit above and a bit below, where people have the sun over their heads. The further up you go, or the further down you go, like the sort of lower angle the sun is. But obviously there's another massive problem with that idea, isn't it, of the sun going up, because that's not what happens. The sun doesn't go around Earth. Okay, stand up. I'm gonna have to squat because I can't make my phone higher. Stand up. You're looking at a screen, I'm looking at a screen. Let's pretend that the screen that we're looking at is the sun, okay? So put your hands on either side of your head and look at the sun. Don't really look at the sun, you know what I mean? So let's say that we are planet Earth and we're going to turn around. So at the moment, the bit of planet Earth that we're on is facing the sun. So it'd be the middle of the afternoon, it'd be lunchtime on our bit, on your face, that is the bit of planet Earth that we're talking about. Okay, so start slowly to turn. Doesn't matter which way you turn. So you start turning and you'll get to a point where, gasp, the sun is going out of sight. The sun's getting smaller. Half the sun has gone. Keep turning. The sun has completely gone now. So it's nighttime. It's nighttime. It's still nighttime. Keep turning. So now I'm facing completely away. So this would be the middle of the night on my bit of the Earth. And now I'm coming back again and keep turning. And eventually there'll be a point where, oh, the sun is back. The sun is just in our sight. And then keep turning, and it's back to the afternoon again. That's how a day actually works. It's just that we can't tell that we're spinning. Like the trees and our houses and the clouds are all spinning, so we can't tell we're spinning. So we think, it looks to us like the sun is moving. The sun is moving a tiny little bit, but not that much. So the other big reason that, right, it's always really difficult. I always end up, to explain seasons and stuff, I always end up holding my globe and saying, imagine my head is the sun. So I made a sun hat this time, because it's the first week back. So imagine no more, children. Here we go. So Earth is actually tilted. So Earth is travelling around the sun like this, on a tilt, and we won't go into this a lot because I know that a lot of you know this already, and we could do a whole lesson on this. But because Earth is tilted, at some point, the whole of the North Pole is facing away from the sun. So it's like always in shade. So these people on the equator, as Earth is turning, they're getting what we just did. Like, oh, the sun's gone away. Oh, it's back. The sun's gone away and it's gone back. You can see, I'm quite pleased with this. Look, I made a ray of sun that comes and hits Earth. Can you see that because Earth is tilted, if you were stood really near the North Pole in this situation, then Earth is turning, but the sun just isn't getting to that bit of the North Pole at all. It's kind of in the shade, right? It's tilted away. And I'm using the north because it's just easier to show you on this globe. So this would be like the middle of winter in the north. And then after half a year, the north gets to this side, then you can see, pretty pleased with this. Can you see there that, because, oh wait, what am I doing? There we go. Now, Earth is tilted towards the sun. There's like a tiny little sliver at the top, so that if you're at the North Pole, actually, the sun never sets for you, and that is true. If you were at the South Pole now, because it's facing towards the sun, you would just sort of see the sun really low on the horizon, just kind of moving around you in a circle. It would never go up, it would never set. So yeah, little interesting piece of information for you here. If you've heard of the Arctic Circle, the Arctic is the bit at the top. The Arctic Circle is like the imaginary line where that starts to happen, if you see what I mean. So the Arctic Circle would be there, just where you can see that ray disappearing. So anyone above the Arctic Circle is in shade all the time in the winter and in sun all the time in sun. Picture. Here, it's nice, isn't it? The Arctic Circle is the lowest point where the sun never sets in the summer, etc., etc. So yeah, this is obviously, it's imaginary. Right, we better do a bit more spinner. Okay, so you've got your two halves of paper. I'm keeping the hat. I like it, and I think I might need it later. Put one piece of paper away. You need to do exactly the same thing to each bit of paper. Exactly the same thing, but we'll just do one piece of paper first. Can you fold your half of a bit of paper in half But this time, can you fold it lengthways? So the long ends meet up. As the person on Instructable said, so it's like a hot dog. Yum, yum, yum. There you go. Fold it in half lengthways. Do a better job than me. I keep saying lengthways. Is that? Yeah, I suppose, as opposed to widthways. Yeah. Fold it in half so the long ends are touching. I'll tell you what, if you're feeling really fast and efficient, do the other one as well, eh? There. Right, I'm just going to show you a nice little picture on the screen that I found that's royalty free. Okay, so you've got that now. You've got 2 pieces of paper that I folded up. So here's, hopefully you can see from this diagram that it's summer in the north, yeah? So north is tilted towards the sun, so Earth's going round, but the people who are right up in the north here, they're seeing daylight all the time. So my question to you is then, why doesn't all the ice in the Arctic melt in the summer? So I've just told you that the poles are, partly the reason the poles are cold is because they're facing away from the sun for nearly 6 months of the year. But that means that they are also facing the sun for nearly 6 months of the year. So why, does that really explain why they're cold? Like, why doesn't all the ice melt in the summer? There's 2 reasons. One reason we've discussed, and one reason we haven't discussed. And I'm going to show you a terrible clue to try and help you get the second reason that we haven't discussed. How you doing? You ready for your terrible clue? All right. So I've got some shiny Christmas paper from a sweet here, and I've got a torch. That's your clue. That's your clue. Shining a torch. Shining a torch onto the shiny paper. Oh, what? Why? Oh. On Facebook, they were all going, reflects. I was like, yes, reflects. What reflects? What reflects? What? What? Shining. Yes, but what is shining? What is what? Okay, so the first reason, which you might have got, well done, is just going to turn this torch off. Not texting someone, that'd be rude. The first reason is this reason. It's the fork activity. Yeah? It's because sun's energy is more spread out at the poles. So that is one reason why all the ice doesn't melt at the poles when it's facing the sun, is because it is less hot there than it would be, say, at the equator. And the other reason is snow and ice reflects heat. It reflects the sun. This is why if you're skiing, you've got to be really careful because you feel like it's cold, but actually you're getting loads and loads of the sun's rays on your face because it's bouncing off the snow. That's why people get that embarrassing sunburn where you can see where their goggles have been. So yeah, this keeps Earth cold as well. It's kind of the poles cold. It's a vicious circle because as global warming is happening, obviously ice and snow is melting because it's getting too hot. But that means that there's less ice and snow to reflect the sun, so that makes Earth heat up more. Right, should we do one more thing with the spinner, and then I'm going to give you a little question sheet, because I've done loads of talking. It's your turn. Right, but next stage of the spinner is get your little hot dog folded piece of paper, and you've got to fold one corner down and the other corner up, all right? So hold it lengthways, long ways. Fold one corner up and one corner down. It doesn't matter which one you do. But what you don't make it like, don't fold both corners down. You're not trying to make a house roof or a boat. You need to make, I've taught this lesson twice on Facebook now, and both times I was like, make this shape, make that shape. What is it? What is it? Is it a rhomba? Is it? And I haven't looked it up, so I still don't know. Make this parallelogram. Looks like a sort of dog, little flappy ear. Make this shape. Make this what you can see. It's a square with 2 triangles stuck on the side at different angles. Trapezium? I don't know. I'm not a maths teacher. There's a poster of it up in our house, and I'm not going to go and look at it. You can look it up in your own time if you're interested. Do this. Make this happen, and then also answer the questions on the board. Here we go. Why are the poles so cold? Can you circle any sentences that are reasons? So, the sun's rays are more spread out at the poles. Is that one of the reasons why the poles are cold? Snow and ice at the poles reflect sunlight. Is that one of the reasons why it's cold at the North and South Pole? Earth's poles face away from the sun sometimes, but does that help to explain why the pole's cold? Earth gets closer and further away from the sun throughout the year, and Earth is tilted. Which ones of those explain why the poles are cold? If you've been to my brand new website, you kind of downloaded the printout, so you can have this in front of you. And if you haven't done that, don't worry about it. They haven't got anything like special and secret. You will see everything that's on the sheet. You could just sort of think with your head what the answer is. So people who are just saying, all of them. It's not all of them, no. Oh, I should say as well, on my Facebook page, if you've got a Facebook account, then the first post on my Facebook page at the moment says, I'm live on YouTube. Comment here if you want to say hello or ask any questions. So if you've got any questions, complaints, accusations, comments, then you can go over to my Facebook page. YouTube doesn't allow comments. Right, let's have a look then. So hopefully you said the sun's rays are more spread out at the poles. Here's your diagram to remind you. Yes, the sun's rays are more spread out. Snow and ice at the poles reflect sunlight. Yes, they do. That is one of the reasons why the poles are cold. Earth's poles face away from the sun sometimes. Yes, that's another reason they're cold. They're in darkness for nearly 6 months. And Earth is tilted. It's basically just another way of saying Earth's poles face away from the sun sometimes, isn't it? So yes, the answer that wasn't correct was Earth gets closer and further away from the sun throughout the year. That is true. Earth does move. It's not in a circle around the sun. It's in a kind of oval shape. But yeah, that doesn't really affect the temperature of Earth. Earth is actually, I think, warmest when it's furthest away from the sun. But it's a thing that a lot of people think. Okay, let's make, well, maybe you're on this already. Now you have to make the other bit of paper look the same as this bit of paper that you folded over. Be careful, the first time I did it I made a mistake. They've got to be exactly the same. So like put it on a table and make sure that you copy it exactly. Don't end up with a mirror image. I ended up with one that looked like that and the other one that looked like a mirror image, and that won't work. So that one's, I folded the bottom left corner up, so I need to do that again on this side. You can use two hands if you like. See? So just put them next to each other and make sure they're exactly the same, not mirror images of each other, right? Okay, so I asked you at the beginning if you thought the poles were the same temperature. Is the North Pole and the South Pole, are they the same temperature? And if you said, no, they are not the same temperature, then you were correct. They're not the same temperature. But actually, if you said, yeah, they're the same temperature, that's kind of right, given the information that you've got so far. So yeah, they're not the same temperature. But based on everything I've just said, they definitely should be, shouldn't they? The sun treats the North and the South Pole exactly the same. The sun is a very fair parent. They both get exactly the same treatment, exactly the same amount of sunlight. So based on everything that I've told you, you would think, yeah, the poles are the same temperature, but they're not the same temperature. Even in the past, I just realised I had to search, has there ever been like ice at one pole and not at the other pole? And scientists think that, yeah, they think that one of them iced over first and then the other one caught up. There's a few different reasons for why Antarctica, the one with the penguins, we will talk about it obviously later in lessons. Antarctica is a continent, it's right at the bottom where the South Pole is, it's got penguins, and it's much colder than the North Pole. In fact, you can almost see one of the reasons why. You see the difference if you look at exactly where this blue thing is joined up to my globe. One of the big reasons is that because of the land and sea difference, they're very different physically. Here we go. So Antarctica, South Pole, right at the bottom, is land. This is a continent, isn't it? This big bit of white here is the land, surrounded by sea, which is blue. Whereas the North Pole is sea surrounded by land, okay? Or, I mean, it's ice. It's hopefully most of the time it's iced over. But it's sea or ice surrounded by land. So if you think of in which situation you would be most comfortable, that might help you remember it. Imagine standing in a puddle surrounded by land, and now imagine standing on a tiny bit of land surrounded by sea. Which one would be more comfortable? Definitely the puddle one, wouldn't it? And it's true that the Arctic at the top, which is ice, water and ice surrounded by land, is much warmer than Antarctica, which is surrounded by the southern sea. Oh, you just fell out of my Lego. For people who are new, this is the setup that I have here. This is what you're dealing with. You're in that. Put you back. There we go. Henry did send me a new design, and to my shame I haven't made it yet because Christmas was busy. But thank you, Henry. I am getting on it. Right, the South Pole is a lot colder. It's like minus 60 degrees Celsius at the South Pole in the middle of winter. And the North Pole, I still wouldn't want to be there, but it's only minus 40 degrees C in the depths of winter. So one of the reasons for that, one reason is the land-sea difference. Another reason is, should I hold these up so that you can see the step that you should have got to with the spinner? Another reason is that the Antarctica is a lot higher up, much, much higher. So this is quite easy to remember, I think, because everyone knows that there's snow on the top of mountains, isn't there? So the higher you go up, the colder it gets. And the Arctic is really just ice floating on water. So you're basically at sea level. You're like a couple of meters above the sea. Whereas Antarctica, we'll talk about this more next week, actually, when we do ice. But in Antarctica, snow has just built up and up and up and up and up and up. And Antarctica is really high above sea level. So that's one of the main reasons why it's colder. There's other reasons as well, like ocean currents. If you've seen Finding Nemo, they like dive into a sort of ocean current to get to places. Obviously, sort of everything on Earth is moving all the time, and the oceans just happen to move in a way that makes the North Pole slightly warmer and the South Pole colder. All right? Some of that I've got a quiz at the end, and some of that's coming up, so I hope you were listening. Okay, I think can we put our spinner together? Can we do it? Are we there? Right, I'll show you. While I talk about ice ages, we'll finish our spinner. So now you need to just put them together so that one's on top and one's on the bottom, and you get this kind of star shape. I've now made like 5 of these, and I never get them to fit quite perfectly. I always end up slightly mashing, so don't worry about it. But you just need to have them both facing the same way, and then put them on top of each other so you get a star. Don't have one upside down so that it looks sort of like a, I don't know, whatever that is, a starfish doing exercises. Put them both the right way around, facing upwards, so you make a star, like that. Just have that ready, and I'll tell you about ice ages. So I learned something about ice ages, actually, for this lesson. I always thought an ice age was just when there was ice at the poles. Like, if there was any ice at the North Pole and the South Pole, then Earth was in an ice age. Turns out that's not actually true. It's an ice age if there's a lot of ice on Earth, and if Earth is particularly cold. Here we go. I wrote it down for you because you might get tested on this as well. An ice age is when temperatures are particularly cold and ice covers a lot of Earth. But actually, during an ice age, there are colder times and warmer times. So during an ice age, there are colder times, which are called glacial periods. You heard of a glacier? More on that next week. So the glacial periods are the very cold bits of an ice age. But there are interglacial periods, which are the slightly warmer times. So it's still an ice age, but you would say it's just a slightly warmer bit of an ice age. So you call it an interglacial period. I guess it's like being winter, but getting a slightly warmer day. Like, it's still winter, but it's just a warmer day. So we're actually in an ice age right now. If you didn't know that, I'm so glad that I get to be the one to break that to you. We're just in an interglacial period. Yeah, I know. It's so good, isn't it? I think it's called the Pleistocene Ice Age. So we're in it, but it had a glacial period, a very cold bit of the Pleistocene Ice Age, ended about 11,000 years ago, I think. And now we're in an interglacial period of the Pleistocene Ice Age. I know, so cool. Right, let's finish. Well, let's do a little bit more about star. Here we go. And then I'll tell you another very cool fact I learned when I was looking up ice ages. So, put them on top of each other, so you've got this star shape. One of the triangles on the bottom, it doesn't matter which one, but choose one on the bottom and fold it over into the square. There we go. This is the bit where I have to do a lot of mashing, but it doesn't matter if it doesn't fit perfectly, it'll still work. You see what I've done there? You know, it's waving. So one of the triangles on the bottom, doesn't matter which one, fold it over so it's inside the square like that, okay? There. So, yeah, when I was looking at this lesson, I was asking myself a few questions like, has there ever been ice at one pole and not the other pole? Turns out that is true. And I also thought, well, has there ever been a time when there's been so much ice at the North and South Pole that the ice has like grown down and down and down and actually covered up the equator? So I looked it up and I found out some very, very good things. When you folded that over, if there's adults in the house, for goodness sake, make them help you. Like, what are they there for? When you've done that, fold over the next one on top of that first triangle, okay? And then fold over the other one on top of that triangle. I can feel some of you panicking, right? Fold over one of the bottom triangles onto the square. Are you watching me? Don't worry about it, just watch me. Then fold the triangle next to it over. And then fold the triangle next to it over. Okay. And then obviously the last triangle goes over, so you make a box. Is that all right? Don't worry. The video, the Instructables is just out there. You can Google Instructables paper spinner after this if you like. So you've just folded all those triangles over on top of each other and on top of each other until you've got a square like that. Right, let me show you this PowerPoint that I did. Earth is 4.5 billion years old. So in the beginning, Earth was extremely hot. The atmosphere contained a lot of greenhouse gases, like a lot of methane, which is a particularly effective greenhouse gas, which just makes Earth heat up, right? Traps heat. And then, well, life popped up about 3 billion years ago, but about 2 billion years ago, living things start giving off oxygen. And this reduces the amount of greenhouse gases and turns Earth into a giant snowball. Yeah, and by the way, snowball is like the proper scientific name for what happened here. So there was so much ice, they just met in the middle of the equator, and Snowball Earth is what they call it. Oh, I love scientists. This obviously isn't actually a photo of that, it's a photo of the moon, an icy moon that NASA took, thanks NASA. So we think that was the first of at least 5 major ice ages. Some scientists are arguing about whether they were snowballs or whether some of them were slush balls, which is also a totally acceptable thing to say for science. Snowball Earth or slush ball Earth. Love it. Right. Oh, sorry. I was blowing my nose. Yeah, so grim. Right, let's make this spin happen. It's like having to come back to the camera to see see if my nose is gross. Okay, you might have guessed what happens next. We tuck this little flap in. And we're pretty much there. You just got to tuck this last flap in to the first flap. Can you see what I'm doing? Tuck it into the little envelope. There we go. So that you've made a square with no flappy edges. Oh, this is the best one yet. Practice makes perfect. Have you done that? So it's just the quiz next, but I'll just tell you a couple more facts that I found out while we're finishing off this spinner. You should have this. I asked you who owns the poles. Who owns the North Pole and the South Pole? The answer is nobody, but it's quite interesting that in the Arctic, particularly the North Pole, there's a lot of oil and gas, and this is what humans burn. We shouldn't. It releases greenhouse gases. It's terrible for the environment, but it makes people a lot of money if they can get their hands on oil and gas. So the countries that own the land around the North Pole, they are allowed to drill for oil and gas, just a little bit off their coastline. And there's this huge big argument going on at the moment because there's a ridge of mountains in the North Pole. And if they work out who owns that ridge of mountains, sort of under the sea, then that country will be able to drill there. So we need to watch the news because at the moment it's great. They can't touch it because they don't know who owns it. If they work it out, it could be really bad. Have you done this? If you've done this, you need to just fold it both ways because we're going to try and make it to spin. So fold it one way so you've got a little triangle, and then fold it the other way so you've got a little triangle, so you kind of make a creasy cross on the bottom. Yeah, quite recently, Russia got away to go underneath the ocean, like under the ice at the North Pole, to go right down to the sea floor, which no one had ever done before. And they put a Russian flag, I'm going to take my hat off. They put a Russian flag in the ocean well, in the ocean floor underneath the North Pole. And all the other countries around the North Pole got really cross and upset. Like, hey, no one owns the North Pole. We're not allowed to own the North Pole. You can't do that. And do you know what Russia said? If you know about science, if you like science, it's a very good answer. Very good answer from Russia. Right, if you've done that, this is probably the hardest bit. Fold it up into a triangle again and hold it and just hold it on both sides and pull it upwards, because what you want to do is make it so that it's got a slightly pointy bottom. See? Like that. Hold it from both sides and then just push upwards so that you get this pointy bottom. Russia says, well, America, because America's one of the countries around the North Pole, Russia said, well, America put a flag on the moon and no one's allowed to own the moon. And America were like, oh, well, it's different. It's quite a good answer though, isn't it? Because yeah, it's illegal to own, no one can own the moon. We all agreed no one can own the moon. And apparently when the astronauts first went up from America and stuck an American flag in the moon, they were quite worried that someone was going to say something. But nobody did. They just kind of got away with it. So yeah, Russia were like, no, we don't say we own the North Pole. We're just saying that we're just pleased with ourselves because we got here and that's a great scientific achievement. I don't know. I'll let you debate it, I hope. Okay, I think we're ready to spin. I'll prop you up on something so you can see my spinner in action. And then we'll do our quiz where I've got 4 questions and there's a letter attached to the right answers and I want you to guess what the word is. So here we go. Get a bit of Lego to prop you up. So, just hold it from both sides. You're going to need both hands for this. Give it a... Ah! Come on! There we go. I think it's really good, that. So you haven't got a great view there, have you? Ah. Hopefully you can enjoy that at home. A nice thing to do, because this is how it tenuously relates to the North and South Pole, is if you put a little picture in the middle, you might want to, I don't know, paint Antarctica in here or something. But if you put any kind of symbol in the middle and symbols at the edge, when you spin it, you'll notice you can see the one in the middle and you can't see the ones on the edge. Do you know why that is? I'll try and show you. I can't really spin it I'll try and spin it with one hand. We have done this in other theatre science lessons. There you go, so you can still sort of see the cross in the middle, can't you? But the crosses on the outside get really blurry. Hey, brilliant. That is because, just before we go, I'm giving you a lot of information, aren't I? It's because it's like on a carousel, the horses on the outside go faster. It's really weird, right? A person stood on the equator, obviously the whole of Earth is turning more or less like all the bits of Earth are turning at the same time. So someone stood on the equator has got to travel around in a massive circle. At the same time, someone stood in the Arctic has only got to move in a tiny circle. So people on the equator are spinning, like moving around at about 1,000 miles per hour, don't quote me on that. Whereas obviously if you're stood actually right at the North Pole, you're not moving at all, you're just kind of rotating. And the same with the South Pole. So that's why. Yeah, it's good, isn't it? Just before I do this quiz, what time is it at the North and South Pole? There is no time. I know, it's so cool. Humans made up time. So if you're on this bit of the planet and you're facing the sun, obviously you don't want it to be midnight. So humans just make, the time is different all over Earth. So if you're stood here and you're facing the sun, that is your midday. And these people have said that it's midnight, the middle of the night. So that obviously when it turns around, then it's their midday and it's their midnight. At the poles, no one lives in the Arctic. And obviously if the sun doesn't come up for like nearly 6 months of the year, there's no point in having time because there's no sun. So it's just whatever time you want it to be. Isn't that cool? If you're on a Russian ship, then you would probably just keep Russian time. If you were doing business with someone in America while you were in the Arctic, you might say it was polite to move to their time. I know. Very cool. Right, finally. Whew, you ready? We've got 4 questions here. And each answer it's multiple choice. Each answer has got a letter. And I want you to say which letter you think is the right answer. And then in the end, you should have a 4-letter word, all right? They're actually really hard. I've made these questions really hard. I think they're like GCSE physics level tricksiness, some of them. So don't worry. I'll do them all once, and then I'll show you them all again before I give you the right answer. So if you're not sure and you want to like check if you've got a word, then you will have a chance to do that. Right, question number 1. What word describes the time during an ice age when Earth is slightly warmer? What word describes the time during an ice age when Earth is slightly warmer? Is it J, a glacial period? Is it B, an interglacial period? Is it T, a galactic period? Or is it S, an intergalactic period? What word describes the time during an ice age when Earth is slightly warmer? J, glacial, B, interglacial, T, galactic, or S, intergalactic. So just write down the word, letter that you think matches the answer. Question number 2. This is hard. Which of these is not a fact about the Arctic? Okay. Which of these is not a fact about the Arctic, where the polar bears live? U, it gets more sunlight than Antarctica. I, it's ice surrounded by land. A, it's warmer than Antarctica. Or E, the North Pole is there. Which one of those is wrong? 3 of those statements are correct, and 1 of those statements is not correct. Which one of these is not a fact about the Arctic? U, it gets more sunlight than Antarctica. I, it's ice surrounded by land. A, it's warmer than Antarctica. E, the North Pole is there. So write down the second letter of your word. Sorry. Question number 3. The South Pole is colder than the North Pole. The South Pole is colder than the North Pole, partly because N, it's at the bottom of the planet. R, it's not, the North Pole is colder. L, it faces away from the sun for half the year. M, it's very high above sea level. Why is the North Pole colder than the South Pole? Is it N, it's at the bottom of the planet. R, it's not, the North Pole is colder. L, it faces away from the sun for half a year. Or M, it's very high above sea level. And finally, which of these is correct? An ice age means there is ice at Earth's poles. Right B. An ice age means a lot of Earth is covered with ice. Right S. There has always been ice at Earth's poles. Right P. F. There has always been an equal amount of ice at Earth's poles. Which of these is correct? B, an ice age means there is ice at Earth's poles. S, an ice age means a lot of Earth is covered with ice. P, there has always been ice at Earth's poles. Earth poles. Earth is hard to say. F, there has always been an equal amount of ice at Earth's poles. All right, those questions again, so you can check your answer. What word describes the time during an ice age when Earth is slightly warmer? Is it J, glacial, B, interglacial, T, galactic, or S, intergalactic? Which of these is not a fact about the Arctic? U, it gets more sunlight than Antarctica. I, it's ice surrounded by land. A, it's warmer than Antarctica. Or E, the North Pole is there. The South Pole is colder than the North Pole, partly because N, it's at the bottom of the planet. R, it's not, the North Pole is colder. L, it faces away from the sun for half the year. Or M, it's very high above sea level. And finally, which of these is correct? B, an ice age means there is ice at Earth's poles. S, an ice age means a lot of Earth is covered with ice. P, there has always been ice at Earth's poles. F, there has always been an equal amount of ice at Earth's poles. All right, the answers. We're in an interglacial period right now. The answer was B. It's not true that the Arctic gets more sunlight than Antarctica. They both get the same amount of sunlight. So the answer was U. The South Pole is colder than the North Pole. I thought this one might catch you out, partly because it's very high above sea level. I thought you might say it's because it faces away from the sun for half a year. Obviously, that's why the South Pole is cold, but it's not why it's colder than the North Pole, because the North Pole also faces away from the sun for half a year. So the reason the South Pole is colder is because it's higher. One of the reasons. And an ice age means a lot of Earth is covered with ice. So well done if you got the word bums. I made you say bums. I'm going to write it on the board. Bums was the correct answer. No, bums. Yeah, last time we did it, it was chumps. I'm going to have to think of more good, rude words. All right, you lot. That is the end of the lesson. That was a long one. Feels like, well, not that long, normal length, but it felt like that was a lot of information to just throw at you. So well done if you lasted throughout those questions. I said that I would tell you how you can pay me if you want to. So it's such a cool business model that I just did accidentally. I started teaching lessons for free during lockdown. sort of for my mental health as much as to help you, to be honest. And then when I thought, oh, it'll just all fizzle out, it just kind of kept going. So I set up this page called Coffee, where you can send me £5 a month. So if you go to my YouTube About section, and you'll see this link to this website called Coffee, or you could just search like Coffee Theatre of Science online. How it works is, most people who watch, I can't believe it, because they really don't have to. Everything is free. All of the lessons that I do are free. I do this, I do IGCSE physics in exactly the same way, Facebook and YouTube. There's printouts for both those lessons. I do a Lego Storytime show, which is on at 10:30 on YouTube today, if you want to check it out. It's on The Legend of the Kraken. And I even do homework for the IGCSE students, and it's all free, and you could just pay me if you want to. I do send you nice things to gently encourage you, and also to say thanks. So if you sign up with £5 a month, I send you Theatre of Science magazine. Husband is a graphic designer, and I am milking this for all it's worth. So it just comes out whenever I've written it. It takes ages and ages to research it, and then write it, and then put it all together. But if you sign up today, I will send you the Weeds issue, which was the latest issue. So it's always got some sort of activity. This one's got a fortune teller that you can cut out to tell you about what Anglo-Saxons used to think about weeds, like sort of from a magic point of view. It's got a beautiful comic about the first woman we know of to travel all around the world. It's got a little quiz about if you see a flower that looks a bit like a dandelion, then you can answer these questions and it'll tell you what it actually is. It's got a card game to help you learn the names of the weeds. I just wanted you to be able to look at the little plants that are growing up through the pavement and appreciate how amazing they are. Because even just a few hundred years ago, we would have been using them for like medicine and food, and now we just spray them with weed killer. It's very sad. So yeah, if you sign up with £5 a month, I'll send you that now as a welcome pack, and some rainbow glasses, and an explanation sheet I wrote about how they work, and some stickers. And if you sign up with £6 a month, I'll send you another Pass magazine, and then you'll just be on the list. So every time the magazine comes out, you'll get one. So the next one I'm working on at the moment is on acids. So you're going to get some little bits of paper that you can test acids with around your house. But yeah, it's coming. I always think it's nearly finished. I'm just going to my Facebook page now. If you've said hello, I'll say hello to you. Yeah, I always think, oh, it's nearly finished. And then the editing process takes ages. So I'll just tell you when I'll tell you when it's nearly ready, the next one. My supporters are very patient people. But yeah, you basically chip in £5 a month towards my wages. And the magazine is like a thank you. Whoa, look at all these comments, brilliant. Just on my Facebook page, because like I say, I put a post on Facebook every time I'm live on YouTube saying, you say hello here if you want to, because YouTube doesn't let you have comments. Oh, look, it's John and Seamus. Hey, hello, brilliant. All right, you two. Happy New Year. Yeah, Happy New Year. Oh, and there's Poppy and Sebastian as well. Hello. Oh, and Grace and Hope are waiting for the live lesson with paper, scissors, and the brilliant handout. Aww. Grace has been loving reading your wonderful magazine. Grace, that was good, wasn't it? It's like you're my marketing partner. Grace has been loving reading your wonderful magazine recently, so many thanks. Thank you, Grace. Thank you. Thank you for your amazing picture that you did. Oh, hello from Amelia and Kitty the cat. Oh, hi, Kitty. Hi, Kitty. Hi. Better not do that. Don't knock the telly over. Oh, Edmund, watching live with his new globe. Nice, Edmund. He says that the ice at the poles has spent a long time getting cold over winter. Oh, yeah, that is good thinking, actually. Yeah, like how if you make a snowman, then all the snow on the grass melts, but the snowman's still there because the snow sort of keeps itself cold for longer. Yeah, that is good. Good thinking. Oh, look, Bella. Everyone was saying this. Everyone on Facebook was saying that Santa owns the North Pole. Santa doesn't own the North Pole, does it? Why are you all saying that? Like, I live in Britain, but I don't own Britain. It's not how it works. Santa can legally drill for oil and gas at the North Pole, but he doesn't own the North Pole. Edward, Annabelle, Evelyn and Rose are watching today. Yeah, you made it live. Hello. Hello, Rose, Evelyn, Annabelle and Edward. Good to, not see you, but you know what I mean. Oh, Lana's here. Hello, Lana. Hello and Happy New Year from Keegan and Caitlin. Hello. Happy Science Day. Oh yeah, you're having Science Day. You're coming to Lego Storytime. It's soon, isn't it? Oh man, I've got to set up Lego Storytime show. It's in 40 minutes. Oh, Laurie and Flynn. Hello. Laurie and Flynn have been in the Science Alliance for like a billion years now. Hey, Nash and Buddy and Sunny. Hello. It doesn't feel like, feels a bit boring that. Buddy, Nash, Sunny. Hello. How are you? What are you up to? I mean, obviously you're watching this. Sorry, you're not giving me much to go on. I hope you enjoyed the lesson. Jay and Daisy and Daniel are here. All right, you lot. Hello. It's Lulu again. You love my sun hat. Yeah, thanks. I'm pretty happy with the sun hat. I mean, I know it's not very physics to have a face on it. The sun doesn't have a face. It's obviously the moon that has a face, but still. Yeah, thanks. Yeah. Bums. I know, right? I know. Don't say I don't know my audience. I know my audience. We're the same, you and I. Oh, hello, Michaela and Tegan. Hello. Ready and waiting. That's good. That's good. Oh, Robin and Snowy the toy dog. Oh, controversial, guys. Robin has been bringing Hissy, the flammable toy snake, to these lessons for, I don't know, Robin, like 3 years. Hissy's having a day off, and Snowy the toy dog is in town. It's a bit controversial. I don't know how I feel about it. Is that, I don't know, is Hissy having a day? Have you killed Hissy? What's happened? Really? You're like, oh, he's having a day off. What happened? Is he angry? Having a day? This all sounds a bit dodgy to me. If I was Hissy, I'd be a little bit worried about this Snowy the dog character. Anyway, Amber. Hello, Amber. Idris and Olwen and Emrys and Karen are here. Hello. That's great, isn't it? Hello, you lot. Planning on it. Excellent. I hope you made it. Ready and waiting. Oh, that's nice. Oh, that's good. Oh, no. Are we doing something wrong? We can't see anything. It still says going live at 60 seconds. I don't know. That might be because I lose my phone before every single lesson. If you saw me 2 minutes before any lesson, I would just be running around the house shouting, "Where's my phone?" This morning I lost my computer. That's a new one. Never done that before. So I found my computer and then the battery was dead. So I plugged it in and then I just sat in front of it like that, being later and later, waiting for it to chug itself into action. So you might have put that comment while all that was happening. Hello, Lizzie. Hey! Oh, Ryder and baby A. Juavia's not here today. There's some funny stuff going on in your house as well. You're like, wait, are Ryder and Juavia the same person? And they can't be in the same... I know that's not true, but baby A. Hello. Hi, baby A. Hello. I didn't know you existed. Hey, baby A. Hey, baby A. It's like a Teletubbies episode, isn't it? Oh, I'm not going to do that. Happy New Year from Arthur and Abba. Check out this infographic about refreezing the Arctic. What? I will. No, I thought it was 10. Can we catch up? Is it stored on YouTube? Yes, you can. You can. Yes, you can watch this on YouTube. I don't know if you can watch it now while I'm still live. I should probably go so that you can watch it and catch up. Hey, all right, Alfie. Hello. Hey, Suki and Oz are in unison. Salah and Musa are here. Hello. Good to see you. Whoops, I got the wrong answer. The children got it right. Yeah, that started happening in my house as well. Yeah. That's good. That's good. You know, that's the best way around, isn't it? All right, Luna. Hoping we can watch in real time. Me too. Are you? I don't know. I think you are, aren't you? Yes, I think you are. Okay, right. I'd better go and and set up Lego Storytime Show, because we're Lego Storytime Show. If you don't know, it's just a chat. So there's no printouts. It's a chat about a thing that I've been learning about this week. Oh, Laurie. Bye, Laurie. I didn't actually say your name, did I? Bye. Hello, Laurie. And also, bye, and thank you for coming. We made the spinner. Oh, that's excellent. Solomon and Edwin and Jeremiah have made the spinner. Yeah, I'm really happy with the spinner. It's quite addictive. Oh, and Mimi and Jimmy and Timmy. Hello. Excellent. See, I knew if I pressed refresh that more of you would have commented. Bella, Dad's not here. It's just... Bella's Dad, why do you hate me? Why do you hate me? Why do you hate education? Do you just not want children to be happy? I don't know. I don't get it. Honestly. It's just the attitude, isn't it? Every week, Bella, it's just the attitude, you know, of your dad that's just upsetting, actually. Playing with a chainsaw today. I mean, Bella, there's phone numbers you can call, mate. There's phone numbers you can call. It was our first one today. Oh, nice. Ethan and Betty. Oh, that's brilliant. Oh, lovely. And then it's just Laurie's comment. Laurie's still laughing about bums. Excellent. Okay, good. Well, now I've... oh, that's so nice. It's really lovely. It's quite a nice way of doing it, actually. Rather than just seeing comments on Facebook like, who else has got a dog? Oh yeah, I've got a dog. It's like, shut up, we're supposed to be learning about the Arctic. So thank you for coming to this YouTube lesson. Right, I've got to go and set up Lego Storytime Show. Thank you so much for all your support. I obviously really appreciate it. I will see you all. I forgot again. I forgot to tell you something. Oh man alive. Right, if you're still here, then your reward is you get this information. advanced preparation for these lessons. Never ever. There's only one activity we ever do where I ask you to prepare something in advance, and it's this activity for next week. We're learning about ice next week. You need to get an empty food can, nearly fill it with water, and about 4 or 5 tablespoons of ice. Mix it all together and put it in the freezer. I just can't believe I forgot to tell people that. So do that now. Can you just do it now? You know, it's not going to really matter if you don't have it, but it's such a good activity. Do it now. Empty food can, water, loads of salt, like 5 tablespoons of salt. Stir it all up, put it in the freezer, and then we'll do something with it next week. Oh, man. Right. Now you can go. Okay. Well done for sticking around. That was your reward, that you are now prepared. I'll see you all next week. Thanks again.